Okay, good afternoon class. So at this point we're looking at algebra. I've done this lesson this morning, but for some reason or other I messed up the video in the recording. Okay, so we are looking at the sum and difference of cubes. Okay, we're looking at the example on page 27. In exercise 1.6 and 1.7 we looked at the product of a binomial and a trinomial in this form, where the first term is squared, the middle term is the opposite operation of the first bracket, and is the product of the first term and the second term, and the last term is being squared. If that is the case, it will result in a difference or the sum of cubes, as you can see here. So when I did the examples with the learners, they were quite confused, so I just wrote it out as follows. If it was the first term cubed plus the second term cubed, if that was the case, which is the sum of cubes, it would have resulted in the first term plus the second term into the first term squared, opposite operation, so it would have been minus the first term times the second term plus the last term squared, the second term squared. Okay. Then also, if that had to be a minus, then the first bracket would have been a minus and the second bracket would have been a plus. Okay. So if at any point you're getting confused in this in these examples, just refer back to this here. Okay. So it will help them when they do that. When we did the exercise, a few sums of the exercise, when we did this here, they understood what needed to be done. Okay. So we're looking at example 1, and example 1 is on page 27, and these are the examples for exercise 1.20 on page 27. The question says factorize. So we have 125a cubed plus 8b cubed. So we ask ourselves, okay, is 125a cubed a perfect cube? The cube root of 125 is 5a, 3 over 3 is 1. And the cube root of 8b cubed is going to be 2b. So yes, this is a case of the sum of cubes. What makes it the sum of cubes? There's a plus between it. Okay, later on when you see a negative between it, it's the difference of cubes. So the cube root of 125a cubed is 5a plus, you will retain the sign of the middle term. The cube root of 8b cubed is 2b. So what we do is we square the first term, so it's 5a squared minus the first term, which is 5a times the second term, which is 2b, plus the last term squared. Okay, which now gives me 5a plus 2b into 5a all squared is going to give you 25a squared. I multiply that, I get negative 10ab plus 4b squared. Do I have to put this middle step in here? No. If you can do this without writing it down and getting it right all the time, you can go straight into that answer there. But since it's initial stages, I would suggest you just write it down. Okay. Just to remind you what's happening. This is exercise example 2, and this is on page 227. Again, the question is to factorize. Okay. So the cube root of 64 is 4. The cube root of x cubed is x. So what we say is going to be simply, so yes, it is the difference of cubes then. So that would give you 4 minus x. So you take the first term and you square it, minus the first term times the second term, plus the last term squared. Okay. So it's going to be 4 minus x, the first term squared, which is 16, which is positive 4x plus x squared. Okay. Let's go to example 3 on page 27. the cube root of 27x cubed is 3x. The cube root of negative 8y cubed is negative 2y. So that is your binomial, this is your trinomial. So it's going to be 3x minus 2y. So we square the first term, it's going to give you 3x all squared minus the first term times the second term, and it's going to be the last term squared. Okay? So we get 3x minus 2y, the first term squared, is going to give you 3x all squared is 9x squared, plus 3x times 2y is going to give you 6xy, plus negative 2y all squared is going to give you 4y. Again, you don't have to write the second step. You can do this at this point without that. Okay, you'll just see me using it all the time. In the next exercise, I won't be using the rule as I am doing it. Okay. There's now example 4. Example 4 is one of two ways I can do it. The cube root of x cubed over 64. That is going to be x over 4 minus the cube root of 1 over 8 is 1 over 2. So what I do is I square the first term. So it's going to be x over 4 squared minus the first term times the second term plus the last term squared. So that simply gives us x over 4 minus half x squared over 16 minus x over 8 plus 1 over 4. That is 1. Okay? Or if I had taken out a common factor, as you can see, I can take out 1 over 8 or 1 over 64. I'm going to go with 1 over 64 to get rid of the bracket of the fraction completely inside the bracket. So it will be x cubed minus. Now 1 over 8 divided by 1 over 64 is 8. Or I can say 1 over 64 times 8 is going to give you 1 over 8. Okay? Which gives me 1 over 64 into. The cube root of x cubed is x. Cube root of 8 is 2. So square the first term gives me x squared. Opposite operation, so it's plus x times 2 is 2x. Plus the last term squared. That is equivalent answers there. Okay, both you'll get a full mark for your sum. Alright. I think the textbook uses the one in blue. Okay, let's go now to example. Here's example 4. I think that was the last example as well. Alright. There was one sum that was an issue here. So what I'm going to do is I'm going to use a similar example to the sum here. Okay? Is when you have, let's go with 27 x cubed minus 8 so it will be 2x plus 3 cubed. Say that was the sum. As you can see, this is also the difference of cubes. So what I do is I take the cube root of 27. The cube root of 27 is 3. 27x cubed is 3x minus the cube root of 8 is 2 into 2x plus 3. Okay? So remember, what do I do with the first time? I squared it, so it's going to be 3x squared. Opposite operation, so it's going to be 3x times negative 2 into 2x plus 3. Okay? Plus the last term squared, which is negative, which is 2 in the negative. So it's negative 2 into 2x plus 3 squared. Alright. This will be another bracket now. I wrote it too closely. So let's just simplify this, gives you 3x minus 4x minus 6 into 9x squared. That is going to give you positive 6x into 2x plus 3, and then plus, that's going to give you 4 into 2x plus 3 squared. Okay. You can add like terms in the first bracket, so it's negative x minus 6. That's going to give you 9x squared plus 12x squared plus 18x plus 4 into 4x squared plus 12x plus 9. Again, whenever we have a negative as the first term, so it becomes x plus 6. You take out negative as a common factor. That's going to give you positive 16, so it's going to be 25x squared. 25x squared plus 12. 25x squared plus 12. 25 is 37x squared. That's going to give you 48. 58 is 66x, I think, plus 4 times 9 is 36. Okay. Let me check something. Okay, and this question was to do with exercise 1.20, number 1S. Okay, we couldn't do that question, so that is just to enhance the examples for that exercise. Okay, I'll stop the video at this point. With this, you should be able to do the first column for homework for tomorrow in exercise 1.20 on page 27.